2.5 kilograms, $2,000. The M72 light anti-tank weapon delivers phenomenal numbers for a device engineered in 1959. This disposable tube started as a temporary solution. Instead, it survived every erasure attempt. 66 continuous years on the assembly line means it outlasted the main battle tanks it was designed to destroy. Physics simply beat procurement theories. The combat record jumped from the Eisenhower era through Iraq directly to modern shipments of thousands heading to Ukraine. The Pentagon tried to replace it twice. Both times, military officials canceled the expensive replacements and purchased the original tubes again. Before these lightweight tubes arrived, American infantry depended on entirely different physical dimensions. A dedicated gunner and a loader desperately attempted to coordinate their movements under incoming fire. Pushing a rocket into the 1.5-meter breach produced a distinct metallic grinding sound that exposed the entire crew. The standard M20 Super Bazooka weighed roughly 6.3 kilograms empty and measured nearly 1.5 meters in length. Carrying this massive structure into active combat immediately turned the operators into highly visible targets. This cumbersome positional weapon was meant for static defense, which starkly contrasted with the new doctrine of rapid maneuver warfare developed during the late 1950s. Seconds were counting down. Those heavy two-man teams had no place in the new tactical manuals. The Pentagon ordered engineers to develop a strictly personal weapon for the individual infantryman. The foundational concept came straight from 1943. During the Second World War, Germany had flooded European trenches with over 8 million disposable Panzerfaust launchers. The logic of total infantry saturation proved highly effective. The United States military decided to copy this exact doctrine of mass distribution. In 1956, the Army issued the formal requirement for a lightweight, single-shot rocket. The Redstone Arsenal initiated the development program in 1959. Hesse Eastern engineers secured the contract and discarded traditional heavy designs. They created a two-piece telescoping aluminum and fiberglass tube. This outer shell contained the solid rocket motor and kept the warhead completely waterproof. The entire package weighed a mere 2.5 kilograms. The firing sequence required no complex assembly under stress. A soldier removed the end caps and gripped the rear section. He pulled it firmly backward. The inner tube slid out to its full extension. A dull metallic click confirmed the locking mechanism had engaged. Spring-loaded sights snapped up into position automatically. The weapon needed zero maintenance in the field. There were no internal batteries to fail, no delicate electronic parts existed. The operator simply aligned the plastic crosshairs and pressed down on the rubberized trigger bar. In 1963, the first crates of the M72 light anti-tank weapon reached active Army and Marine Corps infantry battalions. That engineering elegance collided directly with the combat reality of February 7, 1968. Soviet-built amphibious tanks rolled out of the heavy darkness toward the perimeter wire of the Langvay Special Forces camp. 100 disposable anti-tank rockets stood ready against exactly 11 light armored vehicles. The Special Forces operators grabbed the fiberglass tubes from the defensive trenches. They yanked the telescopic sections open, aligned the sights, and pressed the rubberized trigger bars. Many firing mechanisms simply clicked without ignition, leaving the soldier holding a dead tube. Other projectiles launched out of the casing but failed to detonate upon impact. Unexploded warheads slammed into the 14mm steel hulls of the advancing machines, producing dull metallic clanks instead of the intended blasts. This defensive failure revealed a critical gap between proving ground specifications and battlefield deployment. The rockets required a minimum arming distance of 10 meters, or 33 feet. Ordnance designers included this mechanism as a standard safety feature, intended to protect the infantryman from the lethal fragmentation of his own shot. When the armored vehicles breached the outer perimeter and closed the distance, That exact safety measure rendered the defensive rockets completely inert. The heavy tracks ground straight through the defensive wire, leaving 14 Americans killed or missing in action. The mechanical disaster at Langvay initiated a comprehensive investigation across the entire military command structure. Combat service across Southeast Asia simultaneously exposed an additional defect within the rocket assemblies. Certain warheads detonated randomly mid-flight, scattering shrapnel across the jungle long before reaching any intended target. The United States Army mandated an immediate recall of the entire global inventory. Ordnance depots modified the internal firing linkages and returned the corrected batches to the combat zones. Quartermasters marked these newly issued shipments with a specific painted stencil reading exactly with coupler. The disposable weapon that catastrophically failed its primary mission against 11 PT-76 tanks at Langvay ultimately proved devastatingly effective against an entirely different category of targets. Official records fixated on the tank disaster of 1968, but infantrymen discovered another reality. 66 millimeters. That was the diameter of the shaped charge. When the warhead struck structures, it inverted its copper cone into a superheated jet that bored straight through masonry. A muffled thud echoed inside enclosed concrete spaces. During the 1968 Battle of Hue, Marines assaulted urban fortresses. Thick temple walls stopped rifle fire cold. The 66-millimeter projectile punched right through, wiping out machine gun nests and fortified timber bunkers. Commanders reviewed this urban combat data. The weapon destroyed static defenses. General Staff signed 2 simultaneous orders. The new procurement mandate triggered the search for a replacement. The military wanted a reliable tank killer, but they funded a threat to their own troops. The late 1970s birthed the FGR-17 Viper program. The blueprints promised modern electronics, extended range, and better armor penetration. The physical reality was a fatal design flaw triggered by simple static electricity. During field trials, the prototype accumulated charge in the internal firing mechanism. The rocket detonated directly on the operator's shoulder before leaving the tube. Shrapnel scattered across the test site. The sharp smell of burnt gunpowder hung in the air after the premature explosion. The static problem, a familiar technical hurdle from early rocket designs, remained unsolved. The project collapsed. Congress canceled the Viper. The military had wasted years and millions of dollars, leaving them without a domestic solution. They looked outward. In 1985, the Pentagon selected the AT-4 from Bofors. This Swedish recoilless weapon received the American designation M136 and moved straight to mass production. Engineers originally designed the Swedish launcher to destroy Soviet BMP and BTR infantry fighting vehicles in a hypothetical European war. The 84mm warhead offered reliable penetration against mechanized targets. The AT-4 brought massive firepower, but it introduced heavier weight, larger dimensions, and a higher unit cost. The Pentagon finalized the paperwork. The M72 LAW was officially declared surplus property. The official surplus status crashed into the physics of a dismounted march. A rifleman packed his gear for deployment. He weighed a 6.8-kilogram AT-4 against an M72 tube weighing less than 2.7 kilograms. 2 compact American launchers equaled the exact weight of one new weapon. He hoisted the heavy rucksack. The nylon shoulder straps dug deep into his collarbones. A standard NATO combat load exceeds 40 kilograms, making every extra gram critical during long patrols. For the next 40 years, infantrymen faced a different reality. Enemies drove pickup trucks instead of heavy tanks. They fortified urban concrete rooms. Against unmechanized threats, physical mobility dictated the outcome of every firefight. The world changed. That new world meant clearing one booby-trapped door at a time. Doors meant death. 12,000 Marines and soldiers faced 11 square kilometers of solid concrete. Insurgents abandoned conventional defense during Operation Phantom Fury in November 2004. They transformed a city of 300,000 residents into a monolithic barrier. A classic entry through a front entrance became physically impossible. Architecture dictated the rules. Fighters carved internal passages through shared structural walls. This network allowed them to shift positions without stepping outside. Concrete stopped bullets. Insurgents converted these thick-walled structures into fortified fighting positions with 360-degree visibility. Breaching those fortified positions required a tool that would not steal payload capacity from water and ammunition. How do you punch through a solid wall when the AT-4 rocket launcher weighs 7 kilograms? You grab an old tube weighing 2.5 kilograms. Officials spent 20 years trying to scrap this weapon, yet it became the only viable option for assault teams. The arithmetic of urban combat is strict. A Marine doing 12-hour house-to-house rotations already carried a 14-kilogram outer tactical vest. Every additional kilogram of explosives meant leaving behind hydration packs, rifle magazines, or medical gear. The heavy AT-4 drained stamina. The M72 LAW changed the loadout equation. A soldier extended the 63-centimeter fiberglass tube. He locked the sight. He fired at the reinforced cinder block. Concrete dust crunched under heavy boots and settled over the shattered debris. The newer M72 A6 and A7 variants carried a completely redesigned warhead. Engineers shifted the focus away from tanks. They abandoned deep anti-armor penetration. Instead, they prioritized raw blast effects against static structures. The explosive force blew through walls and detonated inside the rooms. Lightweight proved far more critical than excessive armor-piercing capabilities. The empty tube collapsed easily. Infantrymen slung multiple units over their shoulders and ignored them until the moment of contact. The 2010 after-action report from the 10th Mountain Division recorded the best ratio of mass to combat effectiveness. The combat data from the 10th Mountain Division forced engineers to redesign the internal payload. The weapon that failed to pierce light tanks in 1968 now has a different mission. It rolls off Norwegian assembly lines today. The M72A9 variant, known to British forces as the light anti-structure munition, altered the physics of the strike. A delayed fuse punches through the outer layer of a brick wall. The main detonation occurs a fraction of a second later, trapping the blast inside the room. The fire from enclosure modification changed urban assault tactics. An infantryman kneels in a narrow hallway. He extends the tube and the trigger clicks. The rocket launches from a sealed room without incinerating the operator with backblast. Production shifted from stockpiles to active manufacturing. The heavy hum of automated assembly lines echoes across the Nammo Raufoss plant in Norway. A secondary stream of weapons flows from the Nammo Tally facility in Arizona. This disposable rocket made an unbroken leap from the jungles of Vietnam to the frozen trenches in eastern Ukraine. Canada packed 4,500 units for the new war. Norway opened its reserve depots. 9,500 launchers went to the front line from just 2 states. Those thousands of shipped tubes expose a systemic failure in bureaucratic threat assessment. An infantryman at 3 in the morning will not carry a 22-kilogram javelin to clear a single room. The dead weight of standard gear already crushes shoulders on night patrols. Heavy anti-tank complexes demand dedicated teams. Setup takes valuable time. It remains physically impossible for one fighter to deploy a bulky guided missile while rushing up a narrow concrete stairwell. Instead, the soldier grabs 2.5 kilograms of packed explosive from the armory rack. He straps the green cylinder to his pack. He steps into the dark. He completely forgets the extra load until the exact second a brick wall needs to disappear. Real combat ignores clean procurement charts. Urban warfare happens in tight alleys, not on the vast open plains expected by planners. A modern guided missile costs roughly $200,000 per launch. The unguided rocket costs under $2,000. Physics and basic ergonomics dictate battlefield rules. They strike harder than Defense Ministry schedules. Bureaucrats spent decades trying to eliminate the lightweight launcher. The Pentagon launched 2 separate replacement programs to phase it out completely. Both expensive efforts quickly collapsed. Generals repeatedly declared the weapon obsolete. Then, frontline commanders pulled it from deep storage. They demanded upgrades. They rushed the lightweight tubes straight to active combat zones. Today, factory production lines in Norway and Arizona run continuously. The original engineers at the Redstone Arsenal solved this exact tactical problem in 1959. They gave every rifleman a disposable rocket he could easily carry. 66 years later, the global military industry continues to manufacture that identical fiberglass tube because it never found a replacement.